Hi everyone, James again from Virtual Breadboard. In this tutorial I'm going to look at the new feature, the MPLABX plugin, which you can use to debug PICs and AVR chips from MPLABX. So MPLABX, or just MPLAB, is the development environment for Microchip. Now Microchip own, of course, the PicMicro and the Atmel microcontrollers now. And so this is the industry standard way now of developing for microcontrollers, and over time you'll see a lot of tools merge with MPLAB, and that's one of the reasons is I've got this plugin architecture, and I've used that to create a plugin for Virtual Breadboard where you can connect from MPLABX to Virtual Breadboard to control virtual and virtualized microcontrollers. So let's just do this. We'll do the basic steps. You'll have to learn MPLABX on your own, but I'll just show you how to set up a project from scratch. So we're going to use this example in the example section. In ISCs we have a PIC project ready to go. Now this project is a simple project which you can run straight away. It just uses a switch to change the direction of an LED series. Okay, so that's in hex mode, so this is where I've already preloaded this device with a hex file. The new feature though is where we can click here. You can either be in bin mode, where you can produce a hex file using any tool and then drag it and drop it onto the microcontroller, or you can be in MPLABX mode. Let's try that again, where you'll use this connection key, which will be different for your machine, to connect to the tool. And the way you do that, there's two steps. You first need a plugin. Eventually that'll be part of the MPLAB third-party tools, but for now, while it's in development, you'll get it directly out of the app by clicking Get Plugin. So when you select a folder, it'll copy the plugin into that folder. So when you check that folder, you should see the plugin available. So we put that into the temp folder. Now to install that in MPLABX, so the way you do this is you go to the Tools, Plugins, and you downloaded this manually, so we're going to install this manually. So we'll select from the folder we just saved the plugin, and this is the VBB-X plugin, and we install that. Yep. And we install the plugin, which requires MPLAB to restart. Okay, so now we can create a project. What I'm going to do is I'm going to be using this project source code, but I'll create a project from scratch. So we go File, New Project, Standalone Project. We pick the device. So you need to pick the 16F84A, which is an excellent educational device. Now we can choose VBB-X as the debug tool, now that we've installed the plugin. And we choose MPLAB ASM, which is the default assembly tool. And we call it whatever we want. We'll call it the same name, we'll call it Zigzag. That should create a project for us. Now what we can do is we can add a source file. We'll call it zigzag. So this is the default code. We will copy this code over instead. And build it. Okay, so we've built the project. Now we need to go back and get the connection string. We need to copy this connection string, and we need to go to the tool VBB-X, and we have to paste the connection string here. Okay. So the next thing we need to do is to actually start the virtual breadboard. It's in MPLABX mode now. So when we start it, it should begin a debug session, which it has. And from the plugin now, we should be able to debug Okay, so it's connected, working single step. So here we have the program running under the control of MPLABX. So we can then set breakpoints somewhere. Here we go. And we can then single step and run and inspect the variables. File registers, so we can see inside the file registers. So we can see what's going on. We can also run it and then interact with the switch, which then caused a different section to enter, which hit a new breakpoint. So there you go, that's basically how it works. You use that connection string and the plugin tool to connect the MPLABX project with Virtual Breadboard. Thanks for following along. Bye now.